So this is a very difficult A-star level question, probably one of the most difficult questions ever in an A-level maths exam. Let's have a look through it. Combines quite a few different topics. So if you've done the topic of differential equations, you'd know that you want all the y terms to one side and all the x terms to the other side. In this case, let's divide both sides by y minus y cubed to get 2 over y minus y cubed dy dx is equal to 1 because we're just dividing this side by itself. And then you can multiply both sides by dx to take the dx to the right hand side. Now that all the y terms are on one side and all the x terms are on one side, by the way, you could divide by this 2 if you'd like. I'm just going to leave it as it is now. Either way is fine. You then integrate both sides of the equation. So integral of 1 is just x, and then there's a plus c. But let's focus on the integral on the left hand side because that's quite a bit more difficult. Now it says to express it as partial fractions, and that does help quite a lot. And just to help even more, I'm going to replace the 2 here, leave it outside the integral and just put a 1 here. And we're going to focus on expressing 1 minus y over y minus y cubed as partial fractions. So you can start by factoring out y from the denominator, so it's 1 minus y squared. And you probably spotted now that that's a difference of 2 squares, so you can write this out as 1 plus y, 1 minus y, that in a bracket that is. And then that can be expressed in the form a over y plus b over 1 plus y, and then plus c over 1 minus y. In order to make both sides of the equations match, we need to make each fraction have this same denominator. To make this first term have the same denominator, you multiply both top and bottom by 1 plus y, 1 minus y. So it becomes a lots of 1 plus y, 1 minus y, all over this denominator. That's going to be quite a lot of writing. Sorry if I'm a little bit slow with the writing. Now the second fraction, to make it match this denominator here, you want to multiply not only y but also 1 minus y. So it becomes b lots of y, 1 minus y, all over everything here. I'm just going to put an arrow there. You guys get what I mean. From there, the third fraction, you multiply the denominator by y and 1 plus y. So it becomes c lots of y, 1 plus y. Again, all over this same denominator. I'm just going to cheat a little bit. Now, both sides of this whole equation and this whole equation are equal only when the numerators match, because the denominator is already matching. So we can take the numerator on this right hand side. We can say a lots of 1 plus y, 1 minus y. If you're comfortable with the partial fraction side of things, by the way, you can skip ahead a minute or two. Plus b y lots of 1 minus y plus cy lots of 1 plus y is all equal to this numerator of 1 when comparing both sides. Now, how do you find values of a, b, and c? Well, we substitute in values of y to eliminate individual terms. For example, when you put y equals minus 1 into the whole of the left hand side, this whole term becomes 0. This whole term becomes 0 because 1 take away 1 is 0. But this term here, b times minus 1 is minus b. And then 1 take away minus 1 is 1 plus 1. So that's 2, which is minus 2b, is all equal to the right hand side 1. We can divide both sides by minus 2 and get that b is equal to minus a half. Let's use that idea again. This time let's make y equal to 1, because I realized that when you do that it makes this term here, sorry, I just turned the brightness on, equals 0. 1 minus 1 is also 0, so a, b terms cancel out. Whereas the c term, c times 1 is c, lots of 1 plus 1, which is 2. So that's 2c is equal to 1. Divide both sides by 2 and you get that c is equal to a half. Lastly, to find the value of a, I think it's easiest to compare coefficients of y squared. So like when you expand this out, this would be a times minus y squared or minus ay squared. by times minus y is minus by squared. cy times y is plus cy squared. And then the y squared coefficient on the right hand side is just 0 because there is no y squared term. You can cancel out all the y squareds. And then because we already know the values of b and c, we can substitute that in and we get that minus a minus b, which is minus a half, so plus a half. And then plus c, which is again plus a half, is all equal to the right hand side, which is 0. A half plus a half is 1, minus a plus 1 equals 0, so a is equal to 1. Perfect. Now that we've got values of a, b, and c, we can say that this whole sort of expression here, let's do this in a different color. And I'm just going to check if I can change the thickness of the pen. I feel like it's too thin. Yeah, that's better. Yeah, so we can write this whole thing out now as 2 lots of the integral of a over y. Because we know a is 1, we can write it as 1 over y. Put a bracket around it. And then plus b over 1 plus y, which is minus 1 over 2 lots of this. So I'm right, minus 1 over 2 lots of 1 plus y. And then plus c over 1 minus y. C is a half, so plus 1 over 2 lots of 1 minus y, all dy. Perfect. And the reason I kept the 2 on the left hand side is a little bit of a sneaky thing here. I realized that 2 times a half is just 1, so we can simplify this further now. 2 times 1 over y is 2 over y. 2 times minus a half is minus 1 over 1 plus y. So the 2 here cancels out with the 2 here. Same with the 2 here and here. So leaving you with plus 1 over 1 minus y for that last term. Now, what do we know about integrating ln function? We know that when the numerator is a differential of the denominator, that integrates to ln of the denominator. So if we look at the denominator here, y, that differentiates to 1. So this is 2 lots of ln of the denominator, y. Take away here, if f of x is 1 plus y, that differentiates to 1. So that follows this too, meaning f of x, 1 plus y. We can write the right side as ln of 1 plus y. So minus ln of 1 plus y. And here, this differentiates to minus 1, whereas we have positive 1. So we have to say minus ln of this denominator. If you'd like me to go through this a bit more, I can just let me know in the video. in the comments, and I'll make a separate video just because I don't want to prolong this video too long. And yeah, that's the whole of this integral on the left hand side now, and we can say it's equal to x plus c. Another common question I get, since you're integrating both sides, don't you get constants on both sides? We do, but this constant here is like the constant that you get on this side. Take away the constant that you get on this side, leaving you with that one specific constant, if that makes sense. Perfect. Now what we want to do is write this in the form y equals a function of x. So we need to make it y equal somehow. What do we know about logarithms? Well, straight off the bat, we know the power rule, that if there's a coefficient in front of it, we can bring it forward as a power. We know that when you subtract logarithms and the base is the same, you can divide the insides of the logarithms. So you can say this is ln of y squared over 1 plus y. If you took away the first 2 terms, take away ln of 1 minus y equals x plus c. You can use that subtraction rule again because the base is the same. They're both ln functions. Be a little bit careful here when you divide fractions. So you have y squared over 1 plus y divided by 1 minus y, which is the same as multiplying by the reciprocal of 1 minus y. Meaning the whole of the left hand side can just be written as ln of y squared all over 1 plus y, 1 minus y. I'm just going to write that out as 1 minus y squared. It's going to help us later on. Is equal to x plus c. How do we get just y alone here? Well, we can apply the power of the exponential to both sides, because e to the power of ln of all of this just leaves you with what's inside of that bracket there. So it leaves you with y squared over 1 minus y squared equals e to the power of x plus c, where x plus c is the power. What we know about the addition of powers in indices is that it's the same as the multiplications of the indices. So we can say e to the x plus c, that can be replaced with e to the x, e to the c. Because when the base is the same and you're multiplying indices, you're adding the powers together. So let's do that. Let's write e to the x, e to the c. Now, how do you find y from here? Well, you multiply both sides by 1 minus y squared. So y squared equals e to the x, e to the c, 1 minus y squared. Expand out the brackets. You're able to do that because this is a bracket with the power of 1. So y squared equals e to the x, e to the c times 1, which is e to the x, e to the c. Minus y squared multiplied by all of this. We're almost there now. You can then add y squared, e to the x, e to the c to both sides to bring all the terms with y to one side of the equation. And one last step, which is that, actually, sorry, a few more steps. You can factor out y squared from the left hand side now that only the y terms are on the left hand side. And you can say y squared lots of 1 plus e to the x, e to the c is equal to everything on the right hand side. divide both sides by this bracket that we just formed. So y squared is equal to e to the x, e to the c, all divided by 1 plus e to the x, e to the c. And then square root both sides, and we finally made it to the end. Very difficult question. Hopefully it all made sense. And yeah, if you'd like me to explain this, how when you integrate a function where the numerator is a differential of the denominator, it gives you ln of the denominator, just let me know. But yeah, thanks for watching, and I hope this helped. I have a playlist full of more A-star level questions linked below, so be sure to check that out if you're in the mood to challenge yourself.